Thank you, lady. What was I about to say? Two things. Let me see. There was something. Oh yeah, I'm gonna put. I am gonna do this. Somebody maybe can email me right now and remind me to put up screenshots of 1.3 and 1.4 homework, and then that's it. So some people have their book coming. It's supposed to come next week or something. So I'll put some more homework up there, but I'm not going to do that the whole semester. I'm just not, because that's not good enough. You're missing all the other parts of the book, and I'm not going to screenshot the whole damn book. It just takes too long with the way this stuff works. What else did I want to tell you? Yeah, and everybody saw the link in the module for the extra office hours, right? They're going to be every Tuesday and Thursday starting tomorrow. There's an hour of extra office hours. Okay. I like it. Let me think. Was that all I needed to tell you? I think so. All right. So more people checked in. Anybody else have, let me see. Somebody's still connecting. Somebody's still connecting. Anybody have homework questions or anything? How are you guys doing? Anybody else have any questions, homework questions or anything? Okay. All right. So what I want to do is I want to get a little deeper into some of the math behind what we did yesterday, because I know we did quite a bit yesterday. So I want to do a little bit more of the math behind what we did. So what's interesting is, let me see. Whoop. All right, good. So look, all right, let me spotlight myself. Spotlight Jeff. All right. There I am. Hey. So help me out. How do you guys do, like, how would you do, if you had to do 12 times 8 in your head? How would you do it? If you had to do it in your head.
Put the 8 under the 2 and multiply that. And then
in your head, you can do that in your head, but there's a little bit easier way to do it. Does anyone know an easier way to do 12 times 8 in your head? In your head.
Plus 16.
Say again, sorry?
80 plus 16.
Okay, so what you're doing is this. You're saying this is 8 times 12, which is 8 times 10 plus 2. Let me stop for a minute. I am not saying you have to do it this way, am I? I'm saying this is one way to do these kind of things in your head. You make 12 into a whole number plus extra shit, right? And then you actually do this. Right. You actually do this. You actually do distribute. So you get 80 plus 16, and that's 96, and that's what 8 times 12 is. Let me stop for just a minute. Again, did I say you have to do this ever? In your whole life, do you have to do this? No. All right. I like it. I like it. So couldn't I do this kind of backwards? If I saw 8 times 10 plus 2. Actually, let me start here. If I saw 80 plus 16, I could take an 8 back out. And that is 10 plus 2. Are you guys still able to see that? Yes. No,
can you hear me?
Yes.
Yeah, I usually round it off like that, but I probably would round a smaller number. But I see what you're saying.
I got you. I mean, there are other ways to do that based on, like, you could do, just real quick, since you said that, Leno, I could do 12 times 8 like this, 12 times 10 minus 2. Do you see that? But that's right. Harder. That makes it more difficult. So then you would get 120 minus 24, which is not like immediately easy in your head. It's easier to add in your head than it is to subtract.
Right.
But I mean, it would still work. Still the same basic principle, right? Let me stop for just a minute. Again, I'm not saying to start doing this forever or ever, but I hope it's gonna make some more sense out of. So this I could do. This is kind of a little more silly. It's easy to do 80 plus 16, but math says you could do this if you want to. It's still going to be freaking 96. Okay, so one thing we did yesterday was, let me do another example of this idea. What if I had 11 times, what do you got, Jeff? 15, sure. So what I could do is 15 times 11 is 15 times 10 plus 1. Is that cool? And I love you guys. I know I keep saying this. I'm not saying to do this now forever. I'm not. But math says, yeah, whatever the shit you want to do, this is all legal, right? And then this will be 150 plus 15, so 165, which is a decent, easy way to multiply anything by 11. That's a general rule for multiplying by 11. You do 10 times the thing plus the thing. 10 times the thing plus the thing. That's a cool little trick for 11.
Wow, that's cool.
Thank you. All right, now, so what we did, one thing we did yesterday was we had something like this. Let's say I have a shirt that costs 20 bucks and they're gonna mark it up by 5%. So there's a shirt that's 20 bucks and the store pays 20 bucks for it. So of course they're gonna mark it up so they make some profit. Right. This is not a very smart store because they normally would mark it up by more than 5%. Or I could talk about the Grossmont bookstore and they take a book and they mark it up by 78%, it seems. I don't know. If you bought a book in the Grossmont bookstore, you know what I'm talking about. Welcome to college. All right. So how much money am I going to mark this up by? How much am I going to add on top of 20? How do I figure out that? This is part of what we did yesterday. How do I figure out how much money I'm going to add on top of 20? What does mark up by 5% mean?
Take 5% of 20 and then add it to 20.
Beautiful. 5% of 20. Is that cool? Same way a discount works, except if it was a discount, I would take 5% of 20 and subtract it from 20, of course, because it would be a discount, not a markup. All right. So I would write this as 20 plus, how do I write 5%?
0.05.
Kick ass times 20. So 20 marked up by 5% of 20. That's something else students don't realize a lot is every math equation is actually a sentence. It's just a sentence written in a different language, right? So you can read it in English. Let me stop for a minute. You guys cool with this so far a little bit? If you think about it, we actually did this yesterday. It wasn't 20, it was 1,000. Remember the $1,000 I put in the account? We did exactly this. But I really want to make sure you understand the next step that we took. Looking at what I did over here, and then I was talking about going backwards, what do both of these have? This term and this term, what are they both? They both have what?
A 20.
A 20. So I could take a 20 out. 20 times what is 20?
140?
No, not 20 times 20. 20 times what is 20?
1.
1.
And then this is kind of silly. 20 times what is 0.05 times 20? It tells you it, right?
0.05.
0.05. So see, if I distribute this, don't I get this back? 20 times 1 is 20. 20 times 0.05 is 20 times 0.05. Let me stop for a minute. Let me stop. This was a key step we did yesterday that I think I might have gone through a little bit fast. So the way I could do this way, I could also do it this way. 150 plus 15, they both have a 15. 15 times 10 is 150, and 15 times 1 is 15. So I can take a 15 back out. So if I can multiply two things together, can't I divide them back apart? Of course, right? Math goes both ways. So 20 times 1 is 20. 20 times 0.05 is 0.05 times 20. And then I can do what's 1 plus 0.05. I'll just do it. So if I want to mark anything up by 5%, I just have to multiply it by 1.05. That's the shortcut. All right, so for example, what is 5% of 20? Has anybody done that for me?
5%. I don't got my calculator.
10 cents?
Not 10 cents.
1.
$1. So it'll be 20 plus 1. I get 21. What do you get when you do 20 times 1.05?
21.
21. Of course they're the same because this is the same as this. They're the same. All right, maybe. So now watch what we can do. Watch what we can do. What if I had a car that cost $29,147? I want to mark it up by 4%. What is the shortcut? Now let me just do this and really make sure you can see the connection. What's the shortcut to do this? I would do 29,147 times 1.04. Same thing we do over there. One car plus 4% of the car now. 4% I want to mark it up by. So if it was a 7% account, markup, what would this have been? It would have been
0.07.
1.07. Because again, look what we're doing. Well, look what this accomplishes. What are you guys cool if I write this like this instead? Is that all right? Isn't that okay? Is that okay?
Yes.
And you guys, I can kind of feel some of you guys are like, none of this is okay, Jeff. Who are you doing this at 9 o'clock in the morning? What the hell? Well, oh well, that's what we're all here for. Yeah, so these are the same. Why the shit would I do this? I would not do that for any reason except for right now, explaining why this makes sense. Wouldn't you get 29,147 plus 4% of 29,147? Isn't that exactly what this wants to do? Take the car, add on to it 4% of how much it is. So if I just do this, it accomplishes this because mathematically these are the same. So somebody help me out. What is 29,147 times 1.04?
$30,312.88.
You definitely don't want to forget that 88. What? Do it again. 30,000.
$312.88.
There you go. Okay. That's what that is. And that's, of course, the same thing you would get here. If you did 4% of that and then you added it on top of that. Math sees this and it says, there's got to be a quicker way. And bam, there is. I like it. So that was a key step we did yesterday that I really want you guys to get. Now, let me see. I think that's that piece. I got to remember what it was. I want to do after that. Oh yeah, that's right. We got to do this. So let me do one more example. What if? See, let me do two more examples. So one, what if I mark up by 12% something that costs $48? What's the shortcut way to write that? 48 times, so 4%, 1.04, 5%, 1.05, 12%,
1.12.
1.12, exactly. And then whatever the hell that is. I don't know. Whatever the hell that is. I don't know. $588. Is it 588? I don't know what that is. 58.80. Somebody say
76?
do it again.
Is that right?
What? I think it's
70.
5376.
536. Thank you. All right, now here's the second one. Here's the second one. So this is beyond just this chapter section, right? Do you guys realize this? I mean, this is a generally good thing to know. What about discounts? Because we actually hit discounts more often than we hit markups. Because less of us own stores and more of us shop at stores, and normally they have sales and shit. So what if I had a laptop that normally costs, what do you got, Jeff? $1,400, and it's on sale, discount of, become a C, of 9%. So it'd be 1,400 times. Now for a markup, it's 1 plus whatever the percent is, like 1 plus 0.12. So for discount, it should be 1
Minus.
minus. So what's a whole 1 minus 0.09? You can do it. What's a buck minus 9 cents?
0.91, sorry.
So that completes the whole picture. If I'm going to mark it up, it's going to be 1 plus whatever the markup amount is. If I'm going to discount it, mark it down, it'll be 1 minus whatever. That's what I multiply by. And then, whatever the hell that is. For 40, 14, 126. Wait, don't say anything. Is it, Jeff, 1,274? That's probably too, oh, did I go too far? No, I went the other way. What is it? Somebody.
Got it.
Really?
You got it right.
All right, you got to admit, I mean, that's not bad. I mean, that's my one skill, so I got to show it off sometimes, but you never know. All right. I'm not really a human calculator. I'm not going to do that shit. But
How do you do that?
what's that? You ready?
I came up with 12,600.
You came up with what now?
I don't know how I came up with 600. I mean, not 1274, but it was 1,400
times 0.91.
Oh, okay.
Okay. All right. I'm not going to show you how they did that. That's fine. Yeah. Okay. Good. Good. All right. So coming back to specifically what we have to worry about. Let me see. Because there's this idea I wanted to firm up, and then there's another idea to finish out that section. Let me come back to it. Here we go.
I have a question.
Yes.
So when you put, is that 0.91% or 9? Because I'm aware.
9%. That's 9%.
Instead of adding the 1 to the front, you add it to the back, or?
No. What's a whole 1 minus 0.09?
91.
So
it's 100 by 9.
How did I get 112 here? It was 1 plus 0.12, right? So what am I going to get here? 1 minus 0.09. And what's a buck minus 9 cents?
Oh, 91.
So the easiest way to consider like a whole 1 minus decimals, I think money. Because money is decimals, and our brain latches onto it without even realizing it's decimals. It's just, life to us, right?
Can you hear me, Jeff? Am I muted?
You're good. What's up?
Oh, I didn't know. I thought I was muted. I was thinking to myself, I was wondering the same question. Because I went, I
What
typed
would I
it.
put here if it was a 14% discount? What would I put here?
You would put Wait,
86.
14 point this point negative.
What did you say, Nikisha?
0.86.
0.86.
Multiplied by 0.86.
Yeah, right? Because 14 cents from a buck is 86. So it'd be 0.86 if it was a discount.
Uh,
I like it. What happens if I increase something by 100%? What's another way to
It
say
doubles.
it?
Double it.
Doubles. Because how would I do 100%? It would be 1 plus 1. So an increase of 100% is doubling something. And the math again says, I agree with you, which it has to because we made it. You better agree with us. Okay, maybe. All right, so let me get back in here. We got just a couple things to finish up in this section. And again, I am open to any questions you guys have. We are definitely on track to get through stuff, so I'm not like in a rush. So what I'm talking about is right here. All right, there you go. This step right here. This is the key step we did yesterday because we wrote this down yesterday. Remember, it was 5% increase for this account, 5% every year. So, gosh, this really, I hate doing this, but oh well, it's too bad. All right, here we go. So what we did yesterday was we wrote this as 1,000 times, and if I take a 1,000 out of 1,000, I'm left with 1. So when sorry, say again.
you said you taking what out of 1,000?
Let me watch this. Let me do a little example here. So if I have 7 times x plus 2, how would you simplify that?
Seven x plus 14.
Where?
So when I distribute something in, I multiply it. So what am I going to do when I undistribute, when I take it back out? What if I took a 7 back out? That means 7x divided by 7 is x. I'm going to divide, of course, because putting it in is multiplying, so taking it out is dividing. What's 14 divided by 7?
2.
2. So that's how if putting it in is multiplying, taking it out must be division. Has to be. That's how math works. It does opposite operations to go the reverse way. So how am I going to take out, both of these have 1,000 in it, right? Let me put it down here so you can see it better. So if I take 1,000 out, what's 1,000 divided by 1,000?
1.
1. And what's 0.05 times 1,000 divided by 1,000?
0.01.
And just check me. What do you get when you what's 1,000 times 1? 1,000. And what's 1,000 times 0.05? 1,000 times 0.05. So those are the same. It's just that this step leads to a shortcut that's generally good, and then it leads to a bigger shortcut that we used in these problems. So this shortcut right here is a big one. It's very useful. I appreciate that a decent number of you guys actually saw how useful this shortcut is. This is how I increase anything by 5% is I multiply by 1.05. That's a general rule you can remember forever now. But then what did we do on top of that yesterday? I said, what if I want to do this every year for 70 years? Right? That was that's not this answer here. It's just, I'm going to make up my own. So if I want to do 70 years worth, this is 1 year worth because it's one of these. So if I want to do 70 years worth, it'd be 1,000
Times 7 point?
Careful, times 1.05 to the
70th.
Oh, 7
70,
power.
because I want to apply this 70 times. Now that is a monster shortcut. Instead of doing first year, second year, third year, fourth year, fifth year, sixth year, hey, I'm done. I could just do one step. Freaking apply that 70 times, math. Do it, right? That's your job. Make my life easy, math. It is math's job, by the way, is to make your life easy. I know sometimes it feels the other way around. I don't know if you guys remember, we did this yesterday. I just was thinking back on it, and I felt like I kind of went a little bit fast over this idea of how did I get from this to this? And that's what all this was about earlier, the taking stuff out and how it helps us. Looks like Vu's got somebody messing with this stuff. Let me see. All right. Now the actual questions in the homework don't get that deep. I'm going to clear all this away. Am I recording? I think I am, right? Yes, I had the lady talk to us. I'm going to clear these away unless somebody yells at me. They're going away. There they go. All right. The actual homework, I don't know if anybody's tried to start on the, oh shit, sorry. God, navigating this book online is crazy. There, nope. There's homework. The actual homework is nowhere as freaky. So we're always gonna get, well, let me say this a different way than get freaky. We're always gonna talk about ideas larger than what you have to worry about immediately, because I want you to get the full picture, and then the homework is a little more focused, right? So I know when I lecture, I feel like it's really easy as a student to get freaked the hell out, because I do tend to go on some tangents and explain other ideas. They're not all going to show up directly in the homework, but if you understand all the ideas, the homework you actually have to do should be that much easier. That's my hope. The other thing we haven't discussed is this idea of how to tell what's a linear relationship versus an exponential relationship. So an exponential relationship, so for example, I don't want to do the homework for you, so let me make a different example. I'm going to make an example up on the board. Shapow! You don't have to do, there we go. Don't have to do sound effects. All right. A linear growth means you keep adding the same amount every step. So 1 year, 2 year, 3 years, 4 years. This is like what we did yesterday with the $1,000. Well, after 1 year it was $1,050. After 2 years it was $1,100. I just keep adding 50, right? So how can you tell if a table that you're given represents linear growth? Well, do you just keep adding some amount to get to the next one? So is this linear growth over here? Let me see. Is that linear growth?
Let's see.
Yes.
By 7.
That's
Yeah, because all you're doing is adding 7 every time you're adding 7. Right? Is that okay? No? So that's how you tell if it's linear. So here's one that's not linear. I'll tell you that much. This next one is not linear. I'll make this easy on myself here. Let's see, let's do, well, yeah, we could do that. All right, let's just do this. All right, this gets interesting now. Can you guys see quickly that's not linear? Because what did I add here? 8. And then what did I add next? 24. Okay, whoa. But instead of adding something constantly, what am I doing instead?
Multiplying.
Multiplying. What am I multiplying by?
3.
This is called This is not linear, this is exponential.
So is adding linear and exponential is times?
Yes, I love it. I love it. It kicks so much ass. And again, just to really show you why it's called exponential is because you got 4, and then you got 4 times 3. And then you got 4 times 3 times 3, which is 4 times 3 squared. Isn't that what 36 is? I multiply by 3. I multiply by 2 3s. I multiply by 3 3s. 3 cubed. That's why it's called exponential. Right? This one's called linear because what is it about a straight line? A straight line has to have the same slope. So if this goes up by 1, this has to go up by some amount, and then it's got to keep going up by the same amount. So here the slope would be 7. That's why we call that linear growth, because if I graph it, it makes a straight line. So at the very least, you can definitely tell if it's a linear table. You just see, did they keep adding the same amount? Or if it's not linear, they didn't keep adding, but how do you tell if it's exponential? Well, did they keep multiplying? So let me give you, here's another example. What do you guys think about this table here? Yeah. What do you got, Jeff? I think somebody's exploding. Let me see. All right. So is that table representing linear growth?
No.
All right. Is it representing exponential growth?
Yes.
No. If you said yes, what work did you do? Do you keep multiplying by the same amount?
No.
Times 3 times
4.
times 5. So it's not linear or exponential. So what does it take to be linear growth? You have to add the same amount each step. What does it take to be exponential growth? You have to multiply the same step.
Like division.
Sorry?
Looks like division, like we are dividing, but how now?
If I was dividing, then the numbers would be getting smaller.
Yeah.
Yeah,
So here I can
they
see
are coming.
I multiply by 3 here, right? But then I multiply by, oops, and then I
6.
multiply by, oops. So again, let me do this again. To be linear, you have to add the same amount each step. To be exponential, you have to multiply the same amount each step. And if it does neither of those, then it's neither of those. This one does neither of those. Right? You don't have to be linear or exponential. There's a lot of other ways to grow. Okay. Thankfully, humans, we grow and then we stop growing, or else, that'd be very strange. God, that guy's tall. He's like 60 years old. Whoa. All right. Sorry. Enough. I watched too many sci-fi movies.
So what would be the name for that kind of growth?
This kind of growth is neat because it does seem to have a pattern to it, right? So I love it. You're right. But for now, we just know it's not linear or exponential.
So it's neat.
It's neat for the moment, yes. There is a pattern. Do you guys agree? There's a pattern. Is the pattern linear? No. Is the pattern exponential? No. It's kind of a combination of both, isn't it? Because it keeps multiplying, but what it multiplies by is increasing by the same amount each time. So it's kind of like a nifty combo. But I don't want to get too deep into that. I just want to focus on the two main things, linear and exponential. Okay, I like it. And then you can have a table that's just got nothing to it. There's no pattern, and then it's really nothing. It's not even neat. It's just blah. Okay. All right. So you're going to see some problems in the homework. It's going to give you a table, and it's going to say, is this linear or exponential? And don't just say linear and go on. Explain to me why. You always got to show work. So a few of you guys are turning in stuff with absolutely no work. You will have to redo that shit for sure. All right, this is all about work. That's what I need to look at.
Could I ask a question about the homework, please?
Certainly.
Do we have to write out the whole entire problem?
No.
Okay, thank you.
I already know what those are.
Going to ask same question. Good.
Some people just like to do that. If you like to, I don't mind. You can do it. That's fine. But I already know what the question is, so I don't need you to write that out too. Save some paper. Save the earth. Okay. Let me see. Any other questions before we move on? I'm gonna try something here. I'm thinking. Okay. So let's look at this together. Let's see. I'm going to do a preview of the prep questions at the end of section 1.4. Oh, where's the smoking rates in Canada? Here we go. So look at this table, smoking rates in Canada. So tell me, in Canada, if you are a woman who's 65 and older, how are we doing out there? You guys okay? I'm going to make sure we can read this table. This is 2014, by the way, so who knows what the hell they're doing now. But if you were a woman age 67 in Canada, or all women age 65 and older, what percentage of your group would smoke?
8.4%.
8.4%. I love it. You guys with me? What percentage of all 20 to 34-year-olds in Canada smoke?
24.6. 24.6.
I said all.
4.6.
Oh, 24.6.
I like it, right? So one level of any chart is just, can you read what it's telling you straight up, right? Now let's see a question they asked me. Blah, 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 blah. What group had the lowest overall rate? Holy shit. I'm sorry. This thing just goes crazy. Okay. What group had the lowest overall rate?
12 to 19.
Yeah, be more specific. Because that's not true. That's not the lowest rate I see.
12 to 19-year-old females.
There you go. 12 to 19-year-old females had the absolute lowest rate of smoking in Canada in 2014. I like it. So, I mean, obviously, you can kind of see where we're going in 1.5, possibly. Because these kind of questions are supposed to help us get ready for the next section. That's, of course, the whole point. And what we're actually going to get into in 1.5 is plotting points, right? We're going to get into graphing stuff. So this is kind of slowly leading us in that direction. These are like XY tables here. Remember XY tables? Right, so if I give you an equation, you can do X and Y, and you can pick an X and figure out what the output is. I don't know if you guys remember. Don't worry, if you don't remember, it's fine. We're going to get into it. The number 3 I like a lot, because one of the biggest mistakes people make when they graph stuff is their scale is not consistent, or is not even shown. You got to show me a scale, and what do I mean by the scale has to be consistent? What the hell does that mean? I don't know. So I would get a graph like this. Can you tell me what's kind of like an immediate problem with this graph? Anything stick out to you as a problem?
It's a little hard to see you.
Oh shit. Oh, I'm sharing. I'm sorry. There we go.
The y-axis goes up by 10, then 5, then 5 or 14.
Yeah. This step is 10. Same size step is 5, and then a same size step is 14. Right? So this should not be a straight line if the scale was consistent. Oh, is that towards me or somebody? What's happening out there? Oh, okay, okay. What point is this trying to be? What point is this one trying to be? Let's see if everybody can read it. What axis is this? Let's start there. What axis is this?
X,
X-axis. And what axis is this?
Y.
Y-axis. I like it. Let me stop for a minute. Is everybody cool with that? So we have our normal number line, and then if I want to represent another piece to it, I need to go in the perpendicular direction. Now, just to blow your minds for a minute, not really to blow your minds, but how many dimensions is this representing?
2.
2. And what world do we live in, at least that we can experience directly?
3.
3-dimensional world. So where's the third line?
Time.
Say again? Oh, no, not time. That would be the fourth line. That would be, if, right? We're talking about physical dimensions right now. And it would come, here's the third line coming out of the board. The third line comes out of the board. Anyway, sorry. We're not going to do 3 dimensions all of a sudden. Don't worry. I just wanted to say that real quick because this is 2 dimensions. So the third dimension would have to be perpendicular to both of these. It's got to come out of the board. But let's not do it. Get in there. All right. This point right there is the point 1, 10. So points are always in alphabetical order, X, Y, Z, whatever else of the letters you got. So it's 1 on the X-axis, 10 on the Y-axis. What point is this one?
2, 15.
Yeah, 2 on the X-axis, 15 on the Y-axis. I like it. And of course, this point would be
329.
329. I like it. Now, let me turn my AC on because I'm about to die. Can you guys? Maybe I'll wait. Hold on. Oh man, I just wrote on my curtain. That sucks. Glorious error. Okay, now, if I wanted to redo this graph, this scale looks good because it's 1, 1, 1. What kind of scale should I put here? Because how high up do I need to get on this scale? Up to like 20.
30.
Yeah, so 30 is a good one. It's a nice round number. So maybe I can do 5, 10, 15, 20, 25, 30. So every step now represents the same amount. Let me stop for a second. Yeah, you could have went by tens. You're right, Andrew. I just wanted to give us a little more resolution. Get rid of this stuff here. So if I were to plot those points on a real graph, it would look like 1, 10, 2, 15, 3, 29. So now you can see it's not really a straight line. It looks more like it's curvy. See that? So this looks like it's trying to be linear growth, but we know it's not linear growth. It doesn't keep adding the same thing. This looks more like exponential. It could be, I don't know. It's definitely not linear though, right? You guys semi with me? Okay, maybe. All right. So that's kind of like what this problem is all about here. In a more basic way, this problem right here, it's not dealing with 2 dimensions, it's just dealing with 1, but you got to pick a good scale. So like for part B, I'm not going to put 0, 1, 2, because then to get to 2,500, I'm going to have to tape some pages next to that. So don't do that. What's a better scale maybe for each of these tick marks? That gets interesting. Anybody have a suggestion for a good scale?
500.
Yeah, let's see now. If I put 0 here, it'd be 500, 1,000, 1,500. And you see I'm not up to 2,500.
No.
But Nikisha, there is not a damn thing wrong with picking something, checking it out, because now you know you got to make them a little bigger, right? Nothing wrong with that. So maybe 1,000, right? And maybe somebody else comes up with another one. But as long as every single one of these fits on what they've given you here, that's a good scale. Now, you don't want to make your scale 18 million, right? Because then all your points will be So you don't want your scale to be too small. You don't want your scale to be too big so that all your stuff is like, okay, maybe. So for example, on this, couldn't I have made this 1,000? Wouldn't all the points have fit then? 0, 250, 500.
Can't see you.
Oh, I'm sorry. You gotta excuse me when I do that because I always forget what I'm sharing. I'm not used to sharing my stuff, so it's just a weird thing for me. So could I made this, let me see, 100, 200, 300, 400, 500, 600. That's a consistent scale, right? But then where would all my points have been? They would have all been down here. I wouldn't have been able to see it well enough. So your scale has to have all the data points fit, but also give them room to breathe. So you don't want your steps to be too big. All right, let me stop for a minute.
Do you want to graph? So you want us to graph this out for like A?
Let me see.
3A?
Yeah, the problem they give you, exactly. So you indicate a scale on that number line, and then you plot those points on the number line. So for part A, it's not as bad. The numbers are smaller, but still, if you want to be able to get up to 15, who's got a suggestion for a scale to pick on part A?
I would say 5.
Yeah, you could do 5s. Yeah. Is that the only answer? No. But 5s will work fine. Right? If you put 0 sort of right here, then this will be 5, 10, 15. Right? So that works. Is that the only answer? No. There's other answers that are acceptable. Just I wouldn't use 1, obviously. I wouldn't use 30 because then I have all this unused space. So this
Are we
really
able to use 3, or does it have to be like
3,
5, 10?
0. If I put 0 here, 3, 6, 9, 12, and then 15 is not really on there. So really the point of this is if you use what they give you, what scale will make it fit? So maybe a scale of 4 would work. If I put 0 here, let's
Share
see,
your screen.
4, 8, 12, well, no. Sorry, do it again.
Can you share your screen?
Oh, shit, I'm sorry. God. I cannot wait for us to be back in a room where the screen is reality. So I don't have to switch screens. What was I doing? I forgot. So somebody said, it looks like 5 will be the least you could use. Because you have to be able to go down to 9. So if I put a 0 here, that's 5, -5, -10. And this will be 5, 10, 15. Do you see how it goes up to 15 and down so you can fit everybody? But there's nothing wrong like Nikisha did. She took a guess on this part B, and it turns out it didn't work. And then she knew she had to make it a little bit bigger. No worries. All good. You don't have to get it right in the first guess.
We didn't have to use the 12 then.
Say again?
We didn't have to use 12. We used 5.
Yeah, a scale of 5 is fine because if I do that here, I guess I'm going to do a little bit of this problem for you. So if I put a 0 right here, this will be 5, this will be 10, this will be 15. Then what will this be?
-5.
5, this will be -10. And now can you find all of the points? Yeah, -9 is about right there, and so forth.
Oh, okay. I was
gotta
thinking
have
that we had to use all the numbers to.
Oh, no. It's impossible. Because again, your scale itself must be consistent, must move by the same size steps. But then your numbers can fall wherever the shit they fall in there. So your scale has to have room for all the numbers to go into. Your numbers don't have to fall right on a mark. They can fall in the middle. We know that. They can fall right in between some stuff. No big deal. Isn't that what
I get it.
Yeah, we did that up here, didn't we? Right, 29 fell in between 25 and 30. And... Okay. All right, so, because I don't know if you guys have noticed, I mean, it kind of gives it away when it says lesson 1.5 prep skills, and I make it a part of 1.4 homework because that's supposed to get you ready for the next section. It's crazy. I like it. All right. I don't want to get, let's see, too deep into this. I was trying to leave enough room today for questions if people had them. So this does get into coordinate system, right? So it's called a rectangular coordinate system. This, oh shit, let me share. I love you guys. Okay, here we go. Rectangular coordinate system. All right. You know I do this sometimes. Most of us know about this, right? XY stuff, what we were doing earlier. Most of us have seen that somewhere. And why do we use this? Because if I want to locate a point, and let's say, has anybody ever been to Salt Lake City? Salt Lake City freaks me the shit out. It is so grid-like. It's almost, even for a math person, I'm like, oh my God, this is too much. So it's so grid-like, and you can find somebody's house as if they were on a coordinate system. So if I wanted to find a point, couldn't I say go this many on the x-axis and then go this many on the y-axis? So that's like trying to find somebody's house, this many blocks east and this many blocks north. You guys with me? Maybe? Yes? And I know it's often described as latitude and longitude, but how often do any of us use latitude and longitude? Not much. Maybe some boaters out there, I have no idea, but most of us don't use that shit. We know what it is, but we're like, the only time I care is when there's a hurricane, and even that, I'm in California. Who gives a shit? So I think more like blocks. 3 blocks over and like, what, 5 blocks up. That's how you get to my house, right? You guys with me?
Yeah, I'm following.
All right. There's other ways. So do you see how they say this is the rectangular coordinate system? There's also a coordinate system based on circles that definitely fewer of us ever get to see. Because couldn't I, to get to this point, if I'm standing here, couldn't I tell somebody, okay, turn this much and then walk this far? So turn by so much and then walk this far. Turn by a certain angle and walk. I'm not going to talk more about that. I'm sorry. I just want you to realize why we call it a rectangular coordinate system, because there are a lot of other coordinate systems. This is the most basic and most used one. That's all. We're not going to suddenly start using circular coordinate systems. Don't freak out. They're actually called polar coordinate system, but we're not going to use that. Don't freak out. We're fine. So why do I bring it up? I don't know. I just want to give you a complete picture. So this whole section is all about graphing. And it's going to focus mostly on our XY coordinate system. But they're also going to bring in the idea of data. And you can see why this is called time series data, because it's per year. All right, so I didn't really want to get too deep into this. This, of course, what is this? Okay. I am not being political at all. Just what has happened. So since 2015, it did this, and then it went, of course, right? I'm not saying it's anybody's fault, but that's just what happened. I mean, it went insane. Did it have to go that insane? That's where we get political, and I'm not going to go there. except to say no, it didn't. All right. So I'm not going to get too deep in that. I didn't want to get too far into the next section anyway. Does anyone have any questions? It's about 10 o'clock. I don't want to, I'm trying not to make it like normal that we leave at 10, but I've gotten as far as I wanted to. Does anyone have any leftover questions from something earlier or? Okay.
Yes, yeah.
Yes.
So to see where you corrected, where you corrected the homework, I go can you tell me how to do that again?
Yes. All right, so let me see. You can see my canvas, right?
Yes.
All right, let me become a student. I'm a student now. Oh man, this feels weird. I was done with this. Okay. If you go to grades, right there, right? Grades.
Uh-huh.
And see how this one I graded. So if I click on this,
okay,
it'll come up like this. It seems it's like, okay, what's this shit? But if I click there, I see what you uploaded. If you click here, you'll see my markings. You'll see my little question mark. So you want to hit that view feedback.
Yeah, okay, got it.
You could also download it and print it out or something if you wanted to. It's up to you. But then you'll know exactly what to correct and all that kind of stuff, right?
All right, thanks a lot.
You're welcome. I also had a little video up in there that basically does exactly what I just did, but since we're missing about 14 people, that's why I made a little video, because maybe they'll never be here to see, and maybe I'll drop them. So just remind you guys that are here right now, I appreciate that. This is just like a normal class. If you do miss several classes in a row without communicating with me, I might drop you. Just like a normal, there's nothing different except the classroom is virtual instead of in an actual classroom. That's the only difference. So be careful. If you do have to miss class, I'm not going to drop you just because you missed one day and you were sick and you had to go to the hospital. Just let me know. That's all. Just keep in touch. Okay. All right. Otherwise, I think that's plenty. That's fine. That's plenty. That's a good place to stop. When's our first quiz? You guys remember?
The 29th?
Well, no, that would suck. That'd be Saturday.
31st.
31st. So tomorrow, we will go over a little bit about what's going to be on the quiz. It's going to be, if you look at the homework sheet, it says it's going to be the review section, and then 1, 1, 1, 2, 1, 3, 1, 4. That's what's going to be on this first quiz on Monday. All right. So we will review a little bit tomorrow. All right, guys. I think that's plenty. Just hang out here if you have any other questions. Otherwise, you may log out and go to a different room maybe.
I have a question about 1-3. I'm still stuck on number 6. It says, why do you think the size of a two-dimensional object is like this rectangle? Like this rectangle is measured in square units, like square inches. And I just put because it's not flat. And I don't know if that's...
No, it is flat. That's the thing. A two-dimensional object. So let me share this. All right. So this is flat for sure, right? And it's two-dimensional because it's got a length and a width. But
I had it backwards.
So the idea of area is about how much of this does it take to cover. So what we've decided to do is, all right, if I imagine little squares, how many of those squares does it take? And one of these squares could be like an inch by an inch, so that would be square inches. And then volume would be cubic because it's not only covering, it's also got to fill. So then it's got that third dimension that comes in.
Well, I'm done anyway. Okay. So when they say the cube, it's the one that's like 3D.
3D.
Okay.
And you know, another thing is, if this is so if these are little inches, right? How long is this side?
5 inches.
And then how long is this side? Let's see.
10.
10? So what's the area of this?
50, because I'll do 10 times 5.
50 what? Because 5 inches times 10 inches is 50
Inches.
inches squared. Right?
Squared?
Watch. Tell me this. Tell me this. What's x times x?
X squared.
So what's inch times inch?
Oh, inch squared.
And see how that matches up perfectly with the fact that there are 50 little squares, 50 square inches. So the math matches with the visual.
Yes.
Like, and then the same thing with when I'm filling up a space. So many cubic inches, which matches to the number of little cubic inches. How's everybody else? You guys all right out there?
Will the quiz be with us showing like our video on, or will it be off?
Video on, preferably.
Okay.
Some people don't have the correct equipment, but I prefer the video on. I don't know. I'm going to feel it out. I tried that I gave one of my classes a quiz already. But I want to try all the classes with it this way and see if I want to switch it around, because I don't know. I kind of want to do it during the class time, because that's time that I know everybody should have free. There could be somebody that immediately after class goes to a 14-hour shift job, and then when are they going to be able to do the quiz if I make it due at midnight or something? So I do want to try to keep them within the class time.
Okay.
Yeah. Okay.
Thank you.
You're welcome.
I have a question also about section 113, number 4, the one with the calories an hour one.
Yeah.
So I don't know how to calculate how many calories he would burn if he walked an hour a day for 6 months. Like, I don't know how to calculate that, just because I feel like I'm thinking too much, because I'm like, well, some months have 28 days.
Yeah, I'm curious. I think somewhere they should have said this, or they're relying on me to say this. I don't think they did say this somewhere. But normally with things like that, we do assume that a month has 30 days, because that's close enough.
Oh,
that
okay.
kind of averages out. Because you're right. Because otherwise they'd have to tell me, is it from September to, whatever? Because then, is it a leap year? I mean, my God. So it's, assume that a month has 30 days.
Okay. I do have a second question. So for page 46, number 1, part C, the 1/4 to the 4th power. So I look at that in my head, I'm like, it's 1, because it's
No. Where are we at? Sorry. 1/2. This one, 1/2 to the 4th power.
Yeah, I don't know how to do that.
Now tell me this.
Oh,
How would you do 1A? How would you do 1A by hand, which is the way you should have done it, hopefully? How did you do 1A?
I just 3 times 3 times 3 times.
Yeah. And then you do 3 times 3 is 9, and then times the next 3 is 27. Okay, do the same exact thing with part C. What is 1/2 times 1/2?
Yeah, see, I'm having an ellipses, and I totally forgot how to multiply fractions.
Oh, you just multiply across.
Oh.
In fact, think about it like this. If I cut a pie in half, and then I cut those in half again, and I took 1 slice, how much of the pie did I take?
Wait, hold on. If you cut a pie in half, and then
All right, do it like this. Cut a pie in half, and then take that half. 1/4. So 1/2 times 1/2 is 1 times 1 is 1, 2 times 2 is 4, 1/4.
Okay.
That makes physical sense.
Yes, thank you so much.
In fact, here's a more general rule. If you multiply 2 things that are less than 1, your answer becomes even smaller. 1/2 of a half is even smaller. And then you're going to do half of that and then half of that, because you got 4 1/2s, right?
Mm-hmm.
So it'll be 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. So you do 1 times 1 times 1 times 1, and 2 times 2 times 2 times 2.
Okay, I got it. Thank you.
Well, all right. Anything else, guys? Okay, I'm gonna log out because I got a lot of stuff to grade. I don't see any questions, so see you guys tomorrow.
Thank you, Professor. Have a
Anytime.
good day.